Hello, myself Jeevan Alexen Kavalam, 21BCE5436 here to present the DA1 for Professor Abdul Qadir sir. This DA1 is based on the topic of Nando Tetris, where we implement the project 1 using the Boolean logic and simulate it using some simulation software. In computer science, we often focus on the what of something, not the how. This allows us to use complex tools and systems without having to understand how they work in detail. We can think of this as a process of abstraction, where we focus on the essential features of something and ignore the details. We will build a computer from scratch using this process of abstraction. We will start with the very simple logic gates and build up a complete functioning computer. We will take the lower levels as given and focus on implementing the next level. By the end of this uh, presentation, we will have a complete understanding of how we can uh, build the basic lower level of a computer using the Boolean logic with the help of some simulation software. In the lower level, we use the Boolean algebra. The Boolean algebra can be used to simplify Boolean expressions and to prove the equivalence of two Boolean expressions. We can use the different laws of Boolean algebra such as the associative law, commutative law, distributive law, De Morgan's law, etc. to utilize the functions of the Boolean logic. Boolean algebra is a very important tool in computer science. It is used to design and analyze digital circuits, to implement algorithms, and to write programs. Boolean identities are a powerful tool for simplifying Boolean expressions. They can be used to reduce the size and complexity of expressions, which can make them easier to understand and to implement. Truth values are a valuable tool for verifying the correctness of Boolean expressions. They can be used to show that expression has the desired output for all possible combinations of input values. Now, we design the software hierarchy using the concept of abstraction. Abstraction is a powerful tool in computer science. It allows us to use complex tools and systems without having to understand how they work in detail. We can think of abstraction as a process of focusing on the essential features of something and ignoring the details. We will build a computer from scratch using the process of abstraction. We like at the end of this presentation, we will also learn how to test HTL programs using a hardware simulator. The hardware simulator allows us to interactively simulate the behavior of an HTL program by entering the input values and observing the output values. We can also write a test script to automate the testing of an HTL program. The test script is a file that contains a sequence of commands that tell the hardware simulator what to do. The commands is a test script that can be used to load an HTL program, set input values, evaluate the program's logic, and check the output values. By using a hardware simulator and test scripts, we can verify the correctness of HDL programs before they are implemented in hardware. Hardware simulators are used to test the correctness of HDL programs. Test scripts can be used to automate the testing of HDL programs. Compare files can be used to compare the output of a simulator to the expected value. This allows for systematic and planned testing of complex chips. Like I said earlier, we will get the help of HTL programs to test the Boolean logic of various Boolean functions that we are going to implement in our computer program. HTL programs allow us to test whether our logic is correct or not before we implement it in the hardware that we are gonna use to build our system. This is a very powerful tool to test the correctness of our logic. These are the various Boolean operations: AND operation, or not, and these are some of the Boolean identities. These are very powerful in simplifying the complexity of the hardware that we are going to use, and for uh, improving upon the functionality of the logic that we are going to implement in the hardware. Almost all the Boolean logic gates can be implemented from the basic Boolean gate NAND gate. We can build upon we can build almost all the logic gates by building up this NAND gate one by one. This is the basic truth table for a NAND gate. Now in the project one, we are asked to build the following gates in the SDL program. So some of the gates that we have to implement are NOT, AND, OR, XOR, MUX, DMUX, etc. All these gates are very helpful in building the logic of the computer that we are going to implement. This is one of such gates called multiplexer. A multiplexer enables selecting and outputting one of two possible inputs. A two-way multiplexer. There are many ways multiplexers as well, where we can uh, select and output the input of many inputs. These are widely used in digital design and communication networks. And there is another logic gate called demultiplexer as well. This will act as an inverse of a multiplexer. Now we will move on to the simulation software, where we will input the HTL program and the test script, and we will get the output. The Like I earlier said before, HTL programs are a powerful technique to test our logic before integrating it in our main hardware. Now the steps for implementing the HTL program are as follows. Now, when we create our HTML program, we should use an external text editor to edit the code that we are gonna input into this HTML simulation tool. We cannot use a chip as a chip part in its own implementation, as it does not support recursion. If your HTML code is syntactically correct, the simulation will complete successfully. If there is an error in your HTML code, you will see an error message in red. The hack chipset API is a set of documentation that provides information about the input and output pins of each chip in the hack chipset. We should follow the criteria of the hack chipset API in successfully implementing a correct HTML program. Otherwise, the output may be flawed and the logic may get distorted. Built-in chips are chips that are already implemented and can be used as chip parts in other implementation. The order in which you build the gates is important because some gates depend on other gates. Using as few parts as possible will make your implementation more efficient. Creating an elegant, readable, and well done implementation will make it easier to understand and maintain your code. You must use an external text editor to create your HTML program because the simulator does not have an built-in editor. You cannot use a chip as a chip part in this own implementation because this would create a recursive dependency. If your HTML code is statically correct, the simulation will complete. If there is an error in HTML code, you will see an error message in red. Now I will show you a sample demo of this HTML simulation software, where I input some HTML programs and show you the corresponding outputs. Now first we have to now I'm gonna show you a brief demo on how we can use the HTML simulation software to run the HTML files, so that we can verify the output, and we can use the script to verify the correctness of the output. Now first we have to go to the file option at the top left corner, and we have to load the chip that we are gonna test. Now first I'm gonna do a test on the and.html file. We have to load the chip, and then we have to load the test script file that we are gonna run the test on this particular chip. Now we have to press the double arrow run icon over here to uh, for for the test script to run all the tests on this particular HTL file. Now when we get the successful message at the bottom left corner, we, we we will get a confirmation that our HTL file doesn't have any errors and it successfully ran. Now to get the output of whatever HTL file is giving for this particular test script, we have to change the icon over here to output, and we will get the corresponding output for this particular chip and for this particular test script. So this is a output for the and.htl. Now I will show you a demo for the and16.htl. This is a 16-bit file. Now I'm gonna run the test script as well, and I'm gonna run the test. Now it will compare over all the test files, test scripts, and will show a comparison successful at the end. So we know that the comparison has ended successfully. I will show you the output. So this is the output. Now I will show you one more file. I will show you the dmax.htl, and we will load the test script as well. Now we will run the file, and this is the output for the particular dmax.htl file and for this particular test. So this is my presentation for the DA1. Thank you, Abdul Qadir sir, for giving me an opportunity to present my project.